So wonderful. Good morning, dear LinkedIn community and our members of the EIIF, the European Industrial Insulation Foundation. I have the honor to host today a very special session with Andreas Görtler. He is the foundation director of the EIIF. Welcome to my show, dear Andreas.
Thank you very much, Ilkay. Very happy to be here.
You're welcome. So I've been personally a member of the EIIF since I believe 2018, quite a few years now. And prior to 2018, I've been also a member through a corporation where I was employed before. So I was always enjoying the collaboration with the insulation companies. So today, dear community, we are not talking only about composites, but we're talking more specifically about the thermal part of materials, which is then thermal insulation. And thermal insulation comes in so many different forms. It could be fabrics, it could be nonwovens, it could be pressed mats and things like that are also converted, for example, because I'm talking lately also about converting industry that are, for example, having aluminum foils or coatings like silicone coatings, acrylic coatings, and things like that. But today we're not talking about the materials itself. We are talking today about the environment in that thermal insulation basically is operating. And particularly, I would like to know from Andreas, what are the latest developments in the standards and in the norms? But before we dive into the technicalities, I would like to ask you, Andreas, can you explain my community who is the EIIF? What is the purpose? Is it open for other companies to join this foundation? And if so, who would be the ideal member? Go ahead.
Yeah. Okay, thanks, Ilkay. So first of all, European Industrial Insulation Foundation is a non-profit organization founded in 2009. We are located at the nice area between Lausanne and Geneva at the Lake Geneva. And the purpose of EIIF is actually to initiate concrete projects in industry where we install industrial insulation as one of the best low-hanging fruit energy efficiency technologies, aiming to save energy, reduce emissions, and of course, first of all, and this is very important these days, increase competitiveness of the industrial company, which is investing into technical insulation as we reduce the energy bill and the CO2 emission cost for them. So all in all, and to make it very short, our purpose is initiating concrete projects to save energy, reduce emissions. And your second question, who can join? So EIIF has a very active EIIF membership supporting associations where we have more than 80 members now. And lately, we welcomed also companies which are not exactly manufacturers or contractors of insulation, but using insulation or designing plants and who benefit from the know-how and the exchange and the collaboration which we have in our very active EIIF community.
Mm-hmm. So to this end, you have also, of course, as it's the norm with a foundation, for example, a general assembly. Can you explain what happens at the general assembly? Where does it take place the next time? And if you have already the talking points and if you can release them, just give us an idea how the collaboration works based on the general assembly.
So it's actually a highlight every year. Last year, it was hosted by Saint-Gobain Isover, and we were in the fantastic building of Saint-Gobain Group in La Défense in Paris. And this year, it's hosted by Armacell, so we will be in Münster meeting there. And at the General Assembly, our members gather together and exchange. Of course, we update about newest innovations, which we will also touch upon in this session today here. And we always have a kind of interactive part to trigger the exchange between the members. But we also have the ambition that anyone who's coming to our General Assembly travels back home with some new ideas, some innovative aspects. And also hopefully, because that's also very important for us, has had a lot of fun during the more or less 2 days participating in the EIIF General Assembly. But yeah, mainly, of course, it's to transport information about the activities and to share what is going on, and also if there's innovation, what the innovations are.
Yeah, and because I attended some of these general assemblies already in the past, we appreciate, of course, as members, the transparency that you are giving as a foundation. That means you see also the figures, the income, and what is invested back into the market. So, Andreas, thank you so much about the overview of the EIIF. So, anyone who is interested in thermal insulation, a bit more specifically on the technical side, on the industrial side, then you're welcome to join the EIIF movement. I can wholeheartedly recommend this, of course. Yeah, so let's go into the specifics of insulation. Community, you have to know that thermal insulation as a solution, as a product, is so a wide range of solutions, and a whole value chain is behind this. So from really the raw material suppliers to the substrate suppliers to the ones who then produce ready-to-use insulation mattresses or pipes, and then you got the installing people, and you got a lot of metal work, piping work around the insulation, for example. So there's a whole industry around that. And because it also is always a part of a building or of a machine or a construction, it is also highly regulated. Now, regulations, of course, can be influenced, and the EIIF also is heavily active in proposing standards, norms, and educating his members on these rules. But to be honest, Andreas, sometimes I lose completely track of these developments of these standards. So it's a great opportunity now to catch up with you on all the new things, rather than reading pages of developmental things on the norms. We got you here now. And dear community, if you have a specific question regarding thermal insulation, please drop your comments and questions into the chat, and we will answer them here live or after you've seen it on replay later on. So, energy classes. There are different kinds of energy classes, Andreas, and who developed these energy classes and what they are for?
Yeah, so that was a big jump now, but I'm of course happy to answer. But maybe to link a little bit to the scene as such, because I think that is very important. So in EIIF we have 6 fields of activities. The most known is the tip check program, where we educate and train insulation specialists on how to carry out energy audits according to, and this is why I'm starting with this, the European Standard for Energy Auditing, EN 16247. And the second field of activity we work in is standardization ourselves. So not at the very beginning, but more and more when we were working as EIIF, we were doing more and more tip checks going into plants. In the meantime, we've carried out more than 3,000 worldwide in the same number of plants, of course. We identified that there is actually a lack of standardization when it comes to the energy efficiency performance of technical insulation systems. So what we see in our tip check experience, daily business, we go into plants, no matter if this is in the south of France or the north of Norway, there is a lack of minimum requirements for technical insulation systems and the performance of these systems. And luckily, back in 2009, I think it was in January, it was my first meeting before even starting this job. A group of German engineers came together at the VDI headquarters in Düsseldorf and to discuss, and I want to mention Dr. Martin Zeidler and Professor Henke as 2 of the initiators, with the idea, can we not develop a standard which defines, and this is now going back to your question, Ilkay, energy efficiency classes for technical insulation systems, so that we have a standardized approach which we can offer to industrial clients, how to design the system to make it tailored to the need in the best, let's say, energy efficiency, effectiveness. And this first meeting then developed in the VDI over many, many years. I think it was published in 2018, finally, the VDI 4610. So the group developed, like we all know it from appliances for households like fridges or even from your car, a same idea of putting energy classes in place for technical insulation systems. The challenge for this standard was that if you have a fridge is always the same. It's inside a household, so we talk about 20 degrees ambient temperature. And inside the fridge, you will have most likely something between 7 and 9 degrees. But when we look at industrial applications, we go from minus 150 to 650 and up. And we have very different temperature ranges and situations. We have larger pipes with a large diameter. We have small pipes with a small diameter. And all this plays a decisive role. So what the group of engineers in the VDI developed finally with the VDI 4610 was a standard which would take all this into consideration. So designing a maximum density of heat flow rate as the limiting criteria for a certain energy class. But at the time when this was developed by the VDI group, there was still, let's say, and this is still existing in the sector, I would say, a belief that finally all these kind of things need to result in insulation thicknesses. So that in the best case, you could say, for a DN100 pipe, for example, at 200 degrees, you need to install 200 millimeters of this and that material to be in an energy class C performance. And when we picked up on this, because we saw that worldwide, but especially in Europe as well, there is a lack of standardization to harmonize the energy efficiency profile of technical installations. We need a standard which is completely independent from insulation materials. So no matter if you use a mineral wool fiber or an aerogel or an elastomer or a polyurethane or whatever kind of material you may think of, this standard should define the performance of the product independent from the thickness level, but they all need to achieve the same performance, meaning a maximum density of heat flow rate, which is allowed for the energy class from A to G. So let's say for a wall at some temperature, you would find the maximum density of heat flow rate to achieve is 50 watts per square meter, for example. By the way, on our website at EIIF.org, you will find the energy efficiency class calculator, and you can do your own calculation there, and you will very quickly see that it's a very easy thing to do, but most likely with Ilkay, we will jump on how to use it a little bit later. Now the question was more on the history of the development, right? So what we did was finally, we took the VDI 4610 with the best tip check experts we have in EIIF. We had a close look at it and we said, what is the strength of this standard? What is the weakness? And one of the challenges was it's too complicated. It's a German engineering document, which engineers are happy to read, but we want this standard to be used by anyone. So it should be easy for politicians to, for example, design a regulation. So in the best case, the European Commission would say energy class C is mandatory for any technical insulation system in Europe. If you don't do this, you don't get the permission to produce with your plant as a minimum requirement to avoid that we emit more CO2 than necessary. And of course, if we want to do something like this, the standard has to be simple, because we can't expect that governments start to spend a lot of time to learn how technical insulation systems are designed. So they should have a tool which is very easy to use. Also, what we identified as one of the major issues of our branch is that if someone is designing a plant, they always forget about the insulation. So you have a pipe bridge with all the pipes on top, but there's not enough space to put, for example, an energy class C performing insulant, because you don't have the space for the insulation material. So also for designers in the planning process, the standards should provide a very easy way forward to identify an indicative space requirement for a properly working installation at a certain energy performance level. And finally, what we managed with our TIPcheck experts to develop based on the VDI 4610 is that finally what you need today is 2 parameters only. So you select your energy class C, for example, you check about the operating temperature, let's say 200 degrees Celsius, and you decide what kind of geometry your object has. So this is a DN200 or a DN100 pipe, or it's a wall of an oven or whatsoever. And depending on those 2 parameters, operating temperature and geometry, you just click on calculate, and you can really check that on the website. It's that easy. The standard will give you the output for the energy class from A to G, what kind of minimum energy performance level you have to achieve. With one small specialty, the energy class G is actually anything worse than F. So we calculate F, and anything which is worse than F is then an energy class G. And of course, uninsulated is no energy class, uninsulated is uninsulated. So I think the very good work of this expert group in EIIF, and I'm very proud of this group, and I'm very happy that we managed to develop a standard, a EN standard, EN 17956, in more or less 2 years' time. It was a fantastic cooperation also with the standardization bodies, as everybody very quickly understood that in today's world we need the standard urgently, and we should not waste time on it, because every day we don't insulate, we waste energy and money. It's very simple. So finally, in December last year, the EN 17956 was published and is available now and valid in all Europe and beyond. So Norway, Switzerland, all the CENELEC standardization countries apply to this standard and can be used. So that was a long story for a very short history.
Thank you so much. I'm trying to present your website, Andreas.
Mm-hmm.
Let me see how this works now here in a short way. It looks like
that would be wonderful.
Tile. So let me see if we got EIIF here, Fenster. Okay. Google.
So for anyone, it's EIIF.org, and then in the navigation you see tools, and if you click on tools, you will go to the energy efficiency class calculator, as it's popping up here. Yeah, beautiful.
Yeah. Say again. Where is it?
Yeah. So on the top you see the navigation about us, members join EIIF, and then tools. If you click on tools.
Yeah.
On the top.
Okay, I'm trying to click on my monitor. I have to go on the website. So
exactly.
Tools.
So then you go to tools and energy efficiency class calculator.
Yeah.
Perfect. Then you select, for example, energy class C.
Yeah.
Or let's be more ambitious, take B.
Okay.
It doesn't really matter for the presentation. We take 200 degrees.
Okay. Tell me, why do you take 200?
Because the system we are looking at is an oven, the wall of an oven at 200 degrees Celsius.
Okay, so that the community can imagine what we're doing.
Absolutely. So and then the geometry, we would just choose a wall.
Flat surface. Yeah. Okay.
Exactly. And then you click on calculate, and we will see the familiar graph of the energy efficiency classes. So you just have to scroll a little bit up. Perfect. And you can see on the left side now that the maximum density of heat flow rate is given for each and every energy class. So if you want to be in energy class B, your performance of the system has to be 32 watts per square meter or better. If it's better than 27, you will be energy class A, right? And if you're less good than 32, but better than 40, you will be energy class C. What you can see on the right-hand side is there is an indicative space requirement given based on standard material. So that means, as I said before, for the EPC and designers of plants, they get an idea of how much thickness they should plan around the pipe or around the wall, in this case, for the installation of the insulation material, that they can achieve this energy class. But this is indicative, which means if I have a better performing material, I can maybe achieve this with 300 millimeters. If I have a performance which is not as good, well, then maybe I need to use 400 millimeters. So the standard itself is completely neutral and independent from any material, and the solution can be achieved with any material which is applicable for the certain kind of process. Of course, you can't use an insulation material which doesn't have a maximum surface temperature of 200 degrees. That's of course true. So what you can also see is that with those two parameters only, operating temperature and geometry, anyone can design, can calculate the performance of the insulation system which is needed. So that really means, you don't have to be an insulation expert. You can ask anyone from the bus stop, hey, please calculate the energy class B for a 200 degrees Celsius wall of an oven, and he can do it, he or she. And this is what we feel a big opportunity, first of all, for the designers. And secondly, also when we talk to politicians, they don't need to become insulation experts to think about a kind of regulation possible to achieve energy efficiency also in industry at a good level, and knowing that this is specific for each and every situation you can find on site. Because industry is not all just a fridge, as I said before. I think that's mainly it without going too much into detail.
Yeah. So
thanks very much for showing it.
Yeah, you're welcome. To sum this up, basically, it's very a pragmatic approach to these things, and we have to underline now. Really, this is a standard material, and of course, designers may now say, "Wow, I don't have 340 millimeters, which is the size of a ruler, 30 centimeters, that much space to insulate." But of course, now what comes into place is the material science. Yeah, how do you select the materials? How do you manipulate and convert the materials? Like, do you put now with 200 degrees Celsius, radiant heat is not the part of the radiant heat is not so high, but if that would be a higher temperature, for example, you could put an aluminum foil on it and you get the radiant heat out of the game. Then there are modern materials like Uwe Becker has with these microporous materials. They need much less space. So it really depends on what materials you're using. And then, of course, you can start from here and reduce the space that is required to lower spaces. But it's a great tool, very pragmatic.
Ilkay, I don't want to jump too much into the radiant aspect. So I don't think with the aluminium foil you would solve it. But what you can do, of course, is you can use a two-layer system that you have, as you said, a high-performing material as the first layer, and then you put, let's say, a more standardized or standard, mostly used material as a second layer. But what is really important is you need to check, because this is the innovation. So the insulation world, I would say, is still used to think in thickness tables, because this is usually how the specifications in the plants are still today. So they define for this kind of situation, we use this millimeter with a standard material. What we have achieved with this standard and the maximum density of heat flow rates is finally that we can get rid of being connected to a certain kind of product and really make it independently from the technical solution, design the energy performance. And the way how you get to the energy performance can be very, as I said, can be very, very different. It can be a two-layer system. It can be a very high-performing insulation product. Or if you have the space, and we were looking at the wall of an oven where you usually have the space, or the rooftop of a storage tank, well, then you put the 400 millimeters. So this is not at all a problem. And the nice thing about this new tool, I would even say the standard is a kind of tool for us, is that it's so easy to use and so easy to understand that it gives us the opportunity to talk to target groups we were not able to explain the situation before, because they were not, they were not prepared to go into industrial insulation, deeper insights. They didn't have them. And with this standard, we don't need them. You just think about your fridge. You design C should be the minimum. You see it can be realized. And then it's up to the specialist to design the system which delivers exactly this energy performance.
Okay. So community, you have seen, I've just opened the website, and I had no login here, nothing. It's available for everyone. So go there, play around, and see yourself what comes up with. So Andreas,
maybe just one little advertisement for our members. So this calculator you will also find on our members websites in different languages even. It is not a big issue with the language because there's very little text for the calculator. But on the other hand, it's nice if you have a German website, let's say in the Swiss German speaking part.
Italian,
then you
Spanish,
want the calculator also
French.
be in German. So you can also visit the websites of our members. And if you're considering becoming a member of EIIF, you of course will also get access to this very nice interactive tool to be provided on your website.
Important point. You have also this other app. Will we talk about the tip check app at all today?
We can do. That is very much up to you. So the tip check tool
let's excuse why we are on your site. Can I show this on your website as well?
No. So the tip check tool, you need an access. So the background is the tip check tool is exclusive to certified tip check experts, because there you have to know what you do. The link, Ilkay, is that the tip check tool calculates with the EN 17956 energy classes. So what we do in the tip check tool is that the client we do the tip check for, maybe to quickly explain what tip check is, it's thermal insulation performance or technical insulation performance check. And it's a by EIIF developed standardized energy auditing methodology focusing on technical insulation systems and the potential how much energy we can save and reduce emissions by putting proper insulation there. So the client actually tells us, let's say you go to a chemical plant and you ask him what kind of performance do you want to achieve with the new system? And he would say, let's go for energy class C. So we would put in the tool the energy class C as the requirement. And then when we go through the plant and we analyze the existing insulation, the lacking insulation, so, up to 100 degrees Celsius, we find more or less 10% of the equipment is uninsulated. And here you show, you can click on the login, but then you need the login data. I don't know if I can share the screen.
You can, yes. If you have it handy, then that would be fantastic if you would demonstrate.
No, wait, because now I'm almost short before kicking me out of this session. I have to open a new
window, yes.
Yeah, a new window. Okay.
But if you kick out, you can come back. Don't worry.
Yeah, okay. Okay, so then I would say I can
stop this now, and then you could press the present here or present button.
Okay, I'll check this on my second screen.
Yeah.
So present. Okay, share screen. Is okay? Share screen. And how do I explain him which I want to?
Are you in the Chrome browser? I have to tell you.
Yeah. So I have this.
Chrome. Yeah. So you have to go into Window as far as I saw, and then select the window.
Share. So now you should see the summary table of the tip check tool, correct?
Yes.
Very nice. Yeah. So in the tip check tool, let's go to the project properties. You see here, of course, you give a name. Let's say we call this tip check tool presentation. I won't go through everything. You select the sector you're working in. You define your currency. In Switzerland, we would use Swiss francs. In England, it's pounds. Here we use euros, kilowatt hours. The energy price, CO2 emission factor, depending on what kind of fuel you're using, natural gas, for example, CO2 emission price. And as I said before, you would select the energy class. And then you can, you would go into the plant and do the first component. So let's say we add the component. We are standing in front of an uninsulated component. We click here. It's a pipe. Here we can write a picture reference, either because we take a picture with our infrared camera, and then we note down the name of the picture inside the camera so that we can import it actually, or you make a picture directly of the component you're looking at. Let me just quickly check if select a picture is going to a proper link where I can easily find a nice picture for us.
To avoid people seeing your hard drive,
yeah, okay. Very good. So I'm just going to upload a picture here. Okay. We'll be there in a second. Of course, now I don't find them here. Okay, so actually this is not really a pipe. Now I was selecting not a pipe, but a valve. Let me select the proper picture what we are talking about. So this is a pipe. Yeah. Okay. So we give this a name. We choose the operational time. The diameter. This is a pretty large pipe. So let's say DN400. Length, we estimate we see about 5 meters, uninsulated, medium temperature. Let's say this is 200 degrees, what we had before. We take the average ambient temperature throughout the year. Let's say, oops, not 105, for sure not. 15 degrees Celsius. Average wind speed and the surface material we need in emissivity. We take the general value and click on Save. And now based on the selected energy class, we can see that this pipe, uninsulated, as we nicely see illustrated on the infrared image, is losing 218,000 kilowatt hours a year, of which we can save 214,000, so more than 90%, if we install an energy class C solution. We will reduce more than 40 tons of CO2 every year, and we save our client almost 14,000 euros, depending on the prices which we inserted on the project level. So what you can see here is that the EN17956 is nicely used inside the tool to do a quick estimation on the savings potential. This enables any insulation expert, no matter if he's working for a specific manufacturer of a specific product, insulation product, or an insulation contractor, to do a completely independent energy analysis based on the energy class and the EN17956. So the reporting the client gets is independent from material. Of course, after the tip check, the client wants to know, okay, in my case, what would you propose? What should I install? What kind of material should I use? To which thickness is this solution leading? And of course, the good tip check experts would also note down how much space they have so that they know after the tip check, if they propose a precise technical solution, that this can also be realized on site. And I think this answers best your question about the tip check tool. So in the tip check tool, we do the whole estimation of the savings based on the energy class, and we use the EN17956 to calculate this. And in the designing phase now of the technical solution, this data is handed over to the so-called tip check calculator, but we're not going to present this now because this is too much engineering and too specific. But also in the latest version of the tip check calculator 3.0, we can calculate based with energy classes and then design a specific system, also checking that the energy performance is according to the standard.
Wonderful, Andreas. That was really interesting. And I've showed this specifically, or let you show this specifically, so that the community I'm having is seeing that one effect becomes very clear here. In future, sustainability or CO2 reduction, all these measures that are coming up are related always with investments. And your customers want to know what is the result. How much do I save with this on CO2, but also on energy? And this is a dream case for any salesman in the insulation industry or in any kind of insulation. If you can show now through the energy saving how much money your customer is saving actually on the operation. And what I've seen from these figures, and I know some use cases and reports from the past, the payback of any insulation investment is very short, yeah, because of the energy saving. In some cases, it's 1 year or even less than a year. So it's actually a no-brainer to use thermal insulation. Yet many companies, corporate factories, don't invest into thermal insulation. Andreas, what are the barriers in investing in thermal insulation? Is it a mindset problem, or are there other issues which you may resolve now with the 17956?
Okay, so of course, like always, there's not just one simple answer. So first of all, we can say we have done 3,000 plus tip checks worldwide, and the action rate, so the investment rate, is 75% on average. And of course, this is not true for every, let's say, tip check experience. So we have some which are experiencing even better investment rates, and we have some who show, payback time is 1.5 years. It's €1 million investment, and they save every year half, 700,000, let's say. And still, the energy manager is convinced, super happy about this, goes to the CFO, and the CFO says, I'm really sorry, but at this moment, I don't have money to invest. Boom. So the project is not carried out. So what are the hurdles? What are the challenges? The first one is definitely that these days in Europe, many companies, and let's also not forget, we find very large emission and CO2 saving potential in plants like refineries. And in Europe these days, if you run a refinery, it's maybe not so easy to decide on investments in the future, let's say. However, if the payback time is 1.5 years, the refinery will be there for the next 5 years for sure. So it would be very relevant to do this. And it would be also very relevant to make your refinery as clean as possible if it's so easy and simple. But unfortunately, CFO tactics or strategies are a bit different these days. So either a lack of investment or a kind of attitude, let's wait before we invest, is then sometimes the reason why, even if the figures are super convincing and it's guaranteed that the savings come in a company is still not investing. So I would say this lack of money sometimes, or the special situation we have in Europe, that it's not clear how will the next years look like, and what is, let's say, the role of European refineries in the next 10 years, is a bit difficult. Also in chemical plants, we see that rather ammonia is imported from the US than produced in Antwerp, to give one more example. So there is a lot of uncertainty, and uncertainty is never good for investments. That has nothing to do with technical installation. This is in general true for any investment. So that is one big thing. The next thing is, and this is exactly what we tried to respond to and to get rid of, is the lack of standardization. So the understanding in different companies in different parts of the world, and definitely also in different parts of Europe, on what the impact of an energy efficient technology solution, insulation technology solution, could be for the carbon footprint, for their ISO 50001 management, and so on and forth, is very, very different. So we do know companies who do very good insulation and who have very efficient insulation systems in place. Still, in all the tip checks, we found potential. There's always some uninsulated parts, some heavily damaged part, and some maintenance lacking. This is also why in the AGI group, we developed a new AGI guideline Q07 about maintenance routines. So when to inspect which kind of insulation system, to avoid that we have these large losses on not well-maintained systems, which is unfortunately also something which is not standardized at all. So a lack of standard, a lack of understanding what the minimum energy performance should be is definitely the second most important reason why we have these large energy losses, and why still today, even if you do the tip check and the figures are convincing, CFOs still don't understand that it could be smart to invest into this low-hanging fruit energy efficiency technology. We also have to admit, as a branch, we are very bad in promotion. So all of us, including EIIF. I don't talk here about our communication budget, but it doesn't let us make very big jumps. But this is not the only excuse. Our brands is not used to do active promotion and active acquisition, because the business is not, we don't run the business like this. You can't go to a plant, knock on the front door of the production site. Hey, I'm an insulation company. I would like to insulate your pipes. They do like this and say, come back when I have a project. And this is the normal business we do. So also here with tip check, and it works well. The idea was, you can go to the front door, knock on the door, and ask for the energy manager and tell him that you're offering him a very interesting energy auditing service with a very quick payback and a fantastic return. We calculated in EIIF the price you invest to avoid 1 ton of CO2 is 50 euros. The return on investment was better than 500%. So it is something which is very, very interesting. With tip check, we have the power to actively contact our clients, but also here we have still to learn and to teach the insulation companies. Don't talk to the maintenance guys. They don't have the money and the interest. They need to make sure that with the money they have, the production is run. But the energy manager who, for example, needs to certify 50,001 energy management every year will be super happy to see that there is such an easy technology available for him to demonstrate that he's improving the efficiency of his plant. And also they usually manage to convince the CFO, if they can show, if we don't do this, we don't get the certification for ISO 50001. If we don't get the certificate for 50001, we lose a hell of a money, because we have to show this, or we don't get tax reductions, or we don't get subsidies, or whatsoever. So this is a real driving engine delivering energy efficiency. But as I said before, it's also up to us as a branch to put more effort in the promotion of tip check and the tools we have developed, also of EN 7956 as such, to harvest what we have created, because the potential is out there. And it's a win-win-win for everyone. So for the client, reducing production costs. For insulation, well, this is how you make more business than if you don't do it. And for the environment, we can reduce significantly CO2 emissions. In the latest EIIF study, we estimated a savings potential if we install energy class C everywhere, 160 terawatt hours, 40 megatons or million tons of CO2 emissions. This is not nothing. So let's go. If you listen, let's go.
Yes. So, Andreas, this is a nice self-reflection from your side, and you think you are not, as the thermal insulation branch, not active enough on the promotion of the tools that you have invested in. But I can tell you, you are not alone. So I'm seeing, particularly since I'm active on LinkedIn, so many diverse industries, and they really, excuse me the word, suck on promoting these things. I'm seeing a lot of companies that have extremely exciting solutions, innovations on sustainability, on technology. And that's the reason also why my 3 content pillars are innovation, technology, and sustainability. And I have decided, and this is now the kickoff actually, to introduce a new format that really serves the purpose of promoting sustainability issues, sustainability matters, and solutions. And I call this the innovation, which is being done with the 17956 in your case. Then we got the evolution. Now we have to find ways for the CFO to make him clear on the paper. He can now really see it. There's a payback of 1.5 years. I mean, in which investment, dear CFO, do you see a payback of 1 or 1.5 years? Usually you are working with 10 years or even 20 years of payback time, if that at all, if it pays at all back, yeah? So you have a payback time of 1.5 years. And then the third part is revolution. So we need, if we want to get our climate back to normal, we need revolutionary items. And this is where we need the engineers, that's where we need the CFOs to talk about really investment in these things, like in thermal insulation. In the composites industry, it's the lightweight technologies. And I could go on and on, the decarbonization of planes, for example. All of them are doing innovations in their own laboratory, but no one talks about it. And people's awareness and preparedness to go into these investments are therefore low. And that's the reason why I'm going on this new mission now to get sustainability more into the minds at least on the LinkedIn community, with my humble reach that I created here for the industrial side. So you are not alone, Andreas. This is what I wanted to say. And
That's very good to know.
and thanks for being my kickoff here, the debut. Yeah, and this will be now a series of interviews that I will carry on sustainability. And of course, I deliberately choose you as the number one because here the payback is clear. The 17956, the work you have done is clear. Everything is clear and transparent. So actually, it's a no-brainer to really just, realize this. And I really can't understand the hesitation of the CFO. I mean, the CFO turns in circles. He wants to, increase profits, but he is not prepared to invest money. But once he invested this, in the second year, it's pure profit. Half a million or 700,000 on a 1 million spent, and you just put this into numbers, put it to the bank, get your loan on this, get this finance. Any banker would finance this with one blink of an eye. All right, okay, let's go back then, Andreas, to the 17956. Now, of course, not everyone is an engineer. You have mentioned this also before. That's why you have this very pragmatic tool also freely available on your website. But who is then the 17956 for? Which industries really benefit from the 17956?
Yeah, it's not just industry. So, of course, the first idea is that, and we've seen this example. So in Germany, for example, where the VDI 4610 was published, of course, earlier than the EN 17956, a very active group doing a very good promotion job of the Technische Ausschuss, led by Gerd Gollenstede and Andreas Regel, has managed to get into the most relevant standard in Germany, DIN 4140, the recommendation that an energy class C should be used. And as the German chemical branch is involved in developing this DIN 4140 and agreed to it, companies like BASF, Covestro, and others were checking their insulation specifications to upgrade them to these levels. One of the best examples is Saint-Gobain. So the whole group has in its own insulation specifications now set the demand that they have to install wherever it's feasible and possible an energy class B performance, which is also fantastic in showing walking the talk in the branch itself. But Saint-Gobain is much more than just Isover material. So they have a lot of plants all over the world, which now all need to be insulated with energy class B. So of course the asset owners, the insulation clients are the first target group for EN 17956 and to use this. And you can imagine how easy that is. Instead of having pages of insulation thicknesses for each and every circumstance, you can have one sentence which says our systems have to be insulated with energy class B performance wherever this is feasible and process allows. That's it, one sentence. And then you go to the digital calculator and you calculate when you need to design the system specifically for the DN 150 pipe with 300 degrees inside. So target group number one, of course, that's the first one. And if we can achieve more, like the example in Germany, that it's recommended to use a certain kind of energy class, of course, this is the way to go. The second target group, as I said before, is politicians. So of course, and this is what you said before, average payback 2 years, we know for uninsulated equipment less than 12 months, is very convincing, but still it's happening here and there that companies say we don't invest. The difference too, for example, if you have to achieve a certain kind of cleanliness in your emissions with your chemical production, and for this purpose, you need to put a filter into your chimney because you can't get all these poisonous gases out to the environment. You pay for the filter, and if you don't install it, you're not allowed to produce your chemicals. As simple as that. The filter is never going to pay itself back. It's an investment you have to do because if you don't do it, you don't produce. In our case, technical installation investments pay back. If it's after 12 months, after 1.5 years, after 2 years, maybe for upgrading systems, even after 4 or 5 years, the technical installation solution, reducing your emissions, will always pay back at some point. So there is a payback, and I do believe that with EN 17956, we provide a tool which is straightforward and easy to use for industry to design the systems and make them more energy efficient. So as said before, it's the plant and asset owners, and it's those who design and build plants. Since this year, Linde is a member of EIIF, and of course they're building a lot of plants, and they're running a very ambitious and exciting tip check program inside Linde to push in their client group also for more energy efficient in insulation systems. And Helmut Hüttemann and his team, he himself is a tip check expert, and he has 2 colleagues who are certified as well, are doing a fantastic job as a plant building company. We have a former tip check expert who's now working for an EPC, and also he's driving in the design phase already of plants the idea of the EN 17956. So target groups to be summarized at the end of this session is the asset owners themselves. They are the ones who benefit directly. Politicians to think about wherever necessary, we need to reduce emissions. We can use this standard to easily do this. And then for the plant builders and designers, this is something straightforward, helping them to design the plant in such a way that also energy efficient systems can be applied. That, and then of course, the branch itself, our members, insulation companies, and we offer in the EIIF Academy also very soon online trainings on how to work with EN 17956. Of course, the insulation branch needs to know that the standard exists, how to work with it, and then hopefully also using it in talks with clients to convince clients to do the bit more, which pays off so quickly and delivers energy efficiency in the end.
Okay. Like you just said, we are coming slowly to the end of our live stream. We said that we will be here live on LinkedIn for an hour or so. This will be also broadcasted on YouTube, and we will have a podcast session on this also. So our podcast listeners, hello at this stage. Now, looking 5 years ahead, Andreas, is the 17956 already mature? Is there still work to be done? Where do you see this standard in 5 years?
Yeah. So the standard itself is mature, which doesn't mean that we maybe find here and there smaller things which can be improved. But in general, we don't see big needs so far, and we use it a lot. So the standard itself is ready. Of course, we would love to see either in subsidy programs, so that there is a lack of finance available inside the company, but maybe there's a financing instrument offered by the European Union, for example, for energy efficiency investments. But these energy efficiency investment funds are only given if a certain minimum criteria for the energy performance of the systems are met. So I could imagine that the EU at some time would come up with this kind of energy efficiency fund where you can apply. And if you want to get this money, you have to prove in a very simple, non-bureaucratic manner. You just show the specification for your new system, which costs you 1 million euros, is energy class C performance. And in this fund, it says it has to be at least energy class C, and then you get 20% back from this fund, or you can use money from the fund for a very interesting interest rate to finance this investment. So I could see this happening. Of course, we're hoping for that. We have this wonderful example in the Netherlands that an insulation scan must be carried out every 4 years by industry to identify the losses, and then anything with a payback time of less than 5 years needs to be realized. What is still missing there, and this is what we hope in the next 5 years we can close this gap, there's no recommendation on the performance. So as long as you insulate, fine. And we think, of course, it would be nice then to say, well, if you do this, then do it properly and go at least for a performance of energy class C. So this is two very concrete things we hope to happen. In the very best case, we have a mandatory requirement for industry, in the best case worldwide, to insulate with energy class C. That would, of course, help the fight against the climate crisis best.
Exactly. This is the main part, that we protect this beautiful planet. Yes. So we are coming now to the end. Andreas, thank you so much for everything. Is there anything that we did not cover today that comes to your mind that you want to address finally?
No, I think we managed. I don't know if there's someone who would like to put a question in the chat. If not, the invitation is there. EIIF is non-profit. We are there to give information, so never hesitate to get in touch with us. This is what we are there for. And if we can help you and your production site to become more energy efficient, don't hesitate.
Absolutely. Thank you. So that was also then the final call to action from Andreas, the foundation director of the EIIF. Dear community, so as I said before, this is part of our new format that I'm launching, which is called Innovation, Evolution, and Revolution, and which serves the purpose of getting sustainability technologies and innovation in that area more public and more known. And I would like to influence, of course, that we keep this planet more clean in the future. Andreas, thank you so much for all these insights, and it was a pleasure hosting this session today.
Thank you very much, Ilkay, and good luck with your new format. As we both discussed today, there's a need for it. Thank you.